So good afternoon, everybody, and welcome to this webinar, training webinar from the Symbiosyst Horizon Research Project, webinar which is dedicated to the benefit for sustainable farming and ecosystem functioning in agrivoltaic systems. So thank you, everybody, for the participation. Let me introduce myself. My name is Paolo Picchi from Renewable Energy at Florence Renewable Energy, and I'm responsible for the communication and dissemination of the Symbiosyst Horizon project. And let me introduce my colleague Federica Colucci from Enea, also partner of this research project. Thank you so much. And first of all, we would like to spend a few words to present you the Symbiosyst Horizon project. What are the objectives? What are the topics that we take care about in the research project? So I will share with you a short presentation about the research project. Symbiosyst, creating new synergies between solar energy and agriculture. The premises of the research project. Of course, the rate of installation of photovoltaic rooftop system will not be fast enough to support a rapid energy transition. From the other side, we have been learning so much about the integration of photovoltaics in buildings, and we had so much relevant research about it. Okay.
Sorry, Paolo. Can you share your presentation?
It's not visible yet.
No.
No. So maybe there was yeah. What about now? It's fine.
Yes.
Okay, thank you. So, and large utility scale PV photovoltaic installation in open fields, as we know, are not more an option in many European member states, or maybe are also on the way to not be allowed anymore in some member states, as it's happening in Italy. And so agrivoltaic system is in the unique position to learn from the past mistakes made with integrated photovoltaics in buildings, which delay the development of cost-effective integrated photovoltaic solution accepted by the market. So, well, sorry, I cannot see now anymore the screen. Why? Okay. Can you see the screen now?
Not now.
Now see. Yes, okay.
Okay, sorry, there was some technical problem. So about Symbiosyst. Symbiosyst is a European funded project for the development of novel agrivoltaic systems. What's really the objective, the scope? It's adapted, standardized, cost-effective solution. So in terms of photovoltaic modules and mounting structures, and also in operation and maintenance practice, to the specific needs of various crops in different climates and landscapes. So standard cost-effective solution for the electricity part adapted to different crops and climates and landscapes to find a aesthetically pleasing solution that can be mass manufactured and integrated with the agricultural land in an harmonious way while maintaining the primary goal of farming. And we want to optimize both. All right, so the electric part and the agriculture part. Also to see how we can also adapt some farming schemes and farming approaches to the agrivoltaic systems. And ambition is to create a fully integrated solution from the design to the implementation. And this is the name of the research project, a symbiosis where photovoltaics and agriculture can have a mutually beneficial relationship. And we are eager to learn from existing experience, innovate in our demos, and transfer the knowledge of others. Specific objectives: to develop system technologies adapted to plant variety, geography, and landscape to maximize the crop electricity synergy, to increase the design accuracy along the whole value chain of novel agrophotovoltaic systems to optimize both electricity generation and crop yield. What has been complained in most of scientific literature to the integration into the buildings have to not have given necessary value in all the parts of the value chain in integrating photovoltaics in buildings. So this is what we aim to do in Symbiosyst for the value chain in the integration of agrivoltaic systems in farming and in the landscape. Of course, to increase the performance, reliability, and the ease of maintenance in novel agri-photovoltaic systems, to map, involve, and train the European photovoltaics value chain by leveraging on the experience from the building integrated photovoltaic sector and develop innovative and sustainable business model, to develop sustainable synergic use and system integration for novel agro-photovoltaics to minimize the life cycle assessment, and to increase social acceptance and energy justice through a constant technical social dialogue between stakeholders. So there is a lot of activities in the research project, dedicated work package to the social acceptance and to public engagement with potential stakeholders all around Europe. I see a slide is missing. Okay, it doesn't matter. The Symbiosyst released a position paper last November with specific key messages. So I invite all of you to visit our website, symbiosyst.eu, and to download the read the position paper, where the main key message is that agrivoltaics is experimental. It's a very early, we are in a very early stage of agrivoltaics. So labeling photovoltaics project that greatly constrain farming or significantly impact agriculture yield as agrivoltaics will damage the credibility of these promising disciplines because agrivoltaic research is still in an early stage and would set back already achieved progress, leading to rejection by the public and potential legislative action against PV in general, as we are experiencing, for example, in this exact moment in Italy. Thank you.
Thank you, Paolo, for your short presentation of the project. And I want to just tell that some useful information and that the webinar is recorded. So you can see again the recording webinar on the website. And so I suggest you follow the Symbiosyst page on LinkedIn to stay updated on Symbiosyst new. Feel free to write your question in the box and Q&A. So at the end of the webinar, we can try to answer with our speakers. And now let's start with Francesco Marinello, who is a professor of agricultural mechanics and precision farming at the University of Padua in Italy. And he is talking about the use of electrification in agriculture and how the electrification could support sustainable agriculture. So welcome, Professor Marinello. Would you share your presentation?
Yes, of course. So let me share it. Okay. So you should see now my presentation.
Okay.
Okay. So thank you for the kind invitation, and I'm checking the time, so I will try to stay in my 20 minutes. And I was giving to this short presentation this title: Can electrification support sustainable agriculture? So I would like to start just mentioning that electrification is something that is not so new. So this is a picture taken from Science and Invention more than 1 century ago, and you might see how the idea of electrification is not new at all. So the idea of electrification for tractors, for livestock production, for transportation was already set well defined long time ago. And if you give a look to old tractors, you might find picture like this with tractors or cable tractors that were moved by electrical energy. So electricity has been an option for really long time, and as you might have you might know, this has been only just a good set of ideas, a good set of prototypes, but that has really not come to reality or to actual production. But so the first point I wanted to clarify is that this is something that has been perceived as an option since a long time ago. And electrification has not been standing waiting for something to happen. So it has been integrating into agricultural machinery little by little. First, as you know, of course, with the lighting system, then with some control and with some batteries or with some electrical devices, then with some further control, including also the implement, and then going to hybrid tractor with the fuel engine, but also with electric engine, and coming to the recent days with electric tractors and automatic vehicles. So why electrification? And I would say that electrification and also automation somehow are all together fitting into the same development trend. And this development is targeting first of all, a higher efficiency, also a higher need for flexibility when managing power and transmitting power. Also, the need for lower emission and not secondary, in our case, also higher precision. But the main limitation since I would say 1 century ago is with the autonomy that can be allowed by this vehicle. So I'm moving from the main reason, from the main principle that has been promoting and fueling the electrical power, and I will try to understand together how this system can be fitting then the recent electrical availability through agrivoltaic system. And well, the first reason was higher efficiency. And when speaking about higher efficiency, we should consider the alternatives. And the alternatives are mechanical transmission and hydraulic transmission. And both of them are quite heavy. And the gear transmission of your car will have a weight of some tens of kilograms, hundreds of kilograms in some cases. So very heavy and also very consuming in terms of room, in terms of space needed into the vehicle. Hydraulic systems are probably more light, have less constraint related to the space and the room needed to install hydraulic pipes and pumps and engines. But as you might know, hydraulic systems are suffering because of low efficiency. So electrical systems are a good alternative. Of course, the engine itself is very light, and the issue is, of course, with the batteries. But regarding efficiency, for sure, we can have higher performance than other systems. So it's very practical or very feasible to move and to transfer electrical power up to several meters, and we have experience with kilometers actually. That is something that cannot be done with mechanical, and also with hydraulic it's quite challenging. And when speaking about distances, yeah, batteries are an option, but yeah, electric power can be transferred. Here you see the cable, or also here you see the cable can be transferred at high distances with high efficiency. But speaking about efficiency, we are speaking about also flexibility, and the efficiency of electrical energy is not only because of transferring at long distances, but also the fact that can be converted in other kind of energy. Here you see an example with light energy that you use for this kind of UV treatment of vineyard. Here you see for weeding. But you can convert electrical energy into heating, into mechanical movement, actuation, and so on. So more than other energy sources, the electrical energy can be transferred and converted. So another advantage or another possibility for that is needed by those using mechanical system is avoiding emission. Here you see a kind of example of a gas emission that probably is not so problematic outdoor, but of course gas emission, but also noise might be a problem if you are working indoor. So avoiding emission, noise and gas emission is, of course, an option that is very interesting in some cases. And then I would say that higher precision is also something that is very interesting. Joking with my students, I was asking them if they would never allow a surgical operation to be carried out by a fuel engine. and all of precision medicine system are implementing electrical devices. The same precision, of course, with a different need, but can be achieved or similar one when operating plants or machinery in the field. Here you see 5 or 6 degrees of freedom arm that is harvesting, but without targeting this very high advanced system, we might consider hydraulic system like the PWM nozzle that can allow variable rate spraying, but also electrical mechanical system that can synchronize the hole on the mulching with the specific seed left by the machine, or electrical precision seeding system that can allow variable seeder. All of these systems can be better controlled whenever we are dealing with electrical energy. But let's come to the problem. Autonomy is an issue for sure, and that's, I would say, the main reason why there are so many obstacles to the diffusion of electrical energy into mechanical operation in the field. And probably this graph is sufficient to stress this. With the diesel fuel, 1 kilogram of fuel is enough to operate a tractor, a 100 HP tractor, for 4 minutes. 1 kilogram of lithium batteries will give an autonomy of about 12 seconds. So I would say quite uncomparable and quite difficult to see electrical energy as an actual solution. But this is true whenever we are using high power for a long time. And this is something that might be compared with the actual need of energy. So if we are speaking about plowing, for sure, the amount of energy that is needed plowing at 40 centimeter, moving 4,000 tons of soil per hectare, for sure, the amount of energy is too high. But other operation like indeed seeding, weeding, or spraying or fertilizing are needing a much lower. So the problem is not the tractor, but the problem is find the right fitting with the operation that might be done by that tractor. And converting this in terms of weight of the batteries, if I want to manage a 10-hectare land, so quite a small land, in 5 days, having 2 recharge cycle per day, then I would need about 4 tons of batteries. But the weight is much lower, let's say even lower than 1 ton in the case I am managing with other operation. Here I showing the same result in a logarithmic scale, and you might notice how other operation are having a lower need in terms of weight of the batteries to carry out the operation in the 5 days. So not a matter of what is the tractor, but how we intend to use the tractor. And yeah, going to sustainable agriculture, is electrification an option? Yeah, definitely yes, I would say. In particular for conservation agriculture, that, as you might know, is kind of practice where we are trying to minimize the impact or the disturb on soil, so just making tillage on the very few centimeters, or as for instance in the case of strip tillage, tilling just a tight a thin slice and leaving all of the rest of the soil undisturbed. So minimizing soil tillage is minimizing the energy demand. So if plowing means moving at 40 centimeter plow means moving 4,000 tons of soil per hectare, then, and for this size, we need about, let's say, 4 tons of batteries. Similarly, in the case of conservation tillage, we might reduce the amount of soil to less, I would say, to less than 500 tons per hectare. That is meaning divided by 10 the needed weight of the batteries. So yeah, there is a good fit for sure when minimizing operation, when minimizing tillage. Not only we are reducing the impact of soil, we are enhancing the quality of soil, we are leaving the organic matter on the surface, we are reducing the disturb, keeping a higher biodiversity, but also we can bring the actual advantages of electrification. And advantages of electrification are those that are related to the ability of increasing the efficiency and the control. So increasing the control means giving the possibility of having a better control of my system. Here I'm bringing the example of controlled trophic farming, that is actually something that is more related to the navigation system, but electrical system allow to improve the alignment between my implement and the roads. And this is quite evident if we see this example that is quite effective. So let me show this very simple example. I think you should see the video here. Okay, here, are you seeing my video?
Yes, yes.
Okay, thank you. And this video is a clear example of how a laser control system might operate weeding. And of course, this kind of weeding is something that wouldn't be allowed by a mechanical system. So using electrical energy is a way we can have to increase the precision of our approach. But also we can increase flexibility. I showed the other example, which is quite effective to show, where you see how electrical system can be used to deactivate and to eliminate weeds. So these are just two very probably impressive, but I would say effective example of how electrical energy can be implemented in a flexible and precise way. So sustainability is not only to promote higher sustainability or to promote a lower emission, but also sustainability or conservation tillage is supported by precision farming. And in a recent project where we were operating a live European project, we were working together also with Federica, we demonstrated how combining precision with conservation might maximize the impact in terms of benefits, in terms of sustainability, reduction of environmental impact, and reduction of and increase of economical sustainability. And here you have also some other example. I will leave it to you. These are two links, or maybe the yeah, unfortunately, well, I will skip it because of the Okay, there was some advertisement on that, but you will have access to the presentation. You will maybe check this link that give further understanding of how this precision technology can meet the actual variability in the field. So using the right resource and with the right level of accuracy. So dosing the right, and I'm coming to my conclusion, dosing the right input and the size, tuning the input to the actual need allow to increase efficiency and reducing overuse of resources to reduce losses and waste. And all of this, of course, is allowed whenever we can have this level of control. So I would say that the implementation of electrical energy is not a requirement, but I would say that it well fits with the energy demand that is in conservation practices. Additionally, having using digital technologies and sensing system, these are better fitting energy supply, an electrical energy supply, and the level of precision that can be achieved in the field is unrepeatable with other mechanical or hydraulic system. And this is further true if we are targeting implementation of autonomous vehicle. Nowadays we see autonomous vehicle only for automatic mowers in our gardens, but it is like the trend for the next year to move toward autonomous vehicle. And of course, if I can have energy production that is taking place right in the field, this is somehow closing the loop in the sense that energy is produced in the place where it is to be needed. So no need to transfer tractor and vehicles and autonomous robots to my farm center, maybe taking hours to transfer or asking for my support with my tractor to move system here and there, but having energy directly in the place where it is going to be used, maximize the efficiency and minimize the timing. So yeah, I understand that I was not giving some definitive solution in the sense that I know that electric tractors are still quite expensive and the weight might be somehow of the batteries might be some problem in some case, but I would say that the track that has been traced towards sustainability is well fitting the availability of electrical energy in the field.
Okay, thank you, Francesco. Very interesting, and you underlined that agrivoltaics and energy production holds immense potential to transform our agriculture in sustainable agriculture. So now I will introduce Giuseppe Ferraro. He's a professor of the fruits at the University of Bari, Aldo Moro. And his relation is on grape wine in agrivoltaic system in the South Italy. So it's experimental research. Welcome, Giuseppe.
Okay,
Show your
thank you.
presentation. Okay.
Sorry.
Okay, it's on full screen.
Okay, full screen.
Okay.
Okay, thank you, Federica, for introducing me with this presentation. As you just mentioned, I will give some hints, I will give some data about our experiments on agrivoltaics that we started several years ago. We started work on this mix between energy and electric energy and food energy, maybe I can say, in Veneto region with University of Verona and Professor Maurizio Boselli. because I'm a professor of fruit crops and grapes. So we started working on grapes. And a few years ago, we started these activities on grapes in southern Italy, in Puglia region. These are also my co-workers that are working with me on this trial. So something has been also mentioned by the professor from Padua Marinello, and what is agrivoltaics and why we focused a little bit, on this mix of energy and food production, because maybe we can combine both production without reducing, the soil productivity, but we can give more incomes to the farmers. Every day, we can say that every day we hear, complaints by the farmers because of the higher cost of energy, the higher cost of the sources like fertilizer, like water. So maybe in many situations, the production of either food, of either cereals, fruits, whatever, vegetables, or energy may be something very useful for the farmers and for the community. What about agrivoltaics? There are in the late years there's been a very fast increase in papers focusing on the combination of plants and the solar panels. Although many works were mainly focused on something like not really applied in the field. So simulation studies. Anyway, some reports referred about positive, and negative effects of the presence of the panels in a agricultural field. So some reports refer about shading effects on flower density. So the shade created by the solar panels above, the canopy reduced the flower density, a kind of thinning effect. That in many fruit crops, an agriculture, practices the flower thinning in order to have, a better quality of the fruit, a bigger size of the fruit. Think about, grape, think about apple, think about pear, think about kiwis, and so on. But this shade had also the effect of reducing the alternate bearing, because the alternate bearing is a typical physiological event that occurs in many fruit species, because the plants usually alternate a very high yield in one season and a general lower yield in the successive season. A typical case is the olive. But has positive effects also that the plants or vines grown under the solar panels improve their water status, their water condition, because of the shade, which reduced the transpiration and allowed higher availability of water in the soil. But as drawbacks of the presence of these panels is that the shades can affect some qualitative but also some health aspects of the production, of the crops, such as the pigments. And the production of pigments is so much controlled in plants by the light and the alternance of light and shade, or also about the sugar contents, because the plants needs to photosynthesize and need to accumulate sugars for fruits, for the tissues, for the leaves, for the trunks, for the twigs, and whatever. So there is this reduction. And in this slide, you can see some aspects, that we just mentioned about the different shades and the different density of the panels in an orchard. And this is very important because can affect in different way, the crop yield. You can consider, very low shading levels, which doesn't really affect, the yield of the production, or very high, shading levels, which can affect so much, the crop yield with significant reduction of the production. And we have also to consider, the climate that we can face in the different agricultural areas. So we can have a continental, Mediterranean, or even semi-arid conditions. So with different, starting condition, and we need to think about, the water availability in these areas, the rain amounts that is available in these agricultural areas. And so the panels can be a device which can help the farmers, and not a minor, consideration is the type of species that we can grow in these areas. We can consider herbaceous, vegetable cereals, or even different fruit crops, or even the small fruits. We can see in this slide the interaction between, the shade and the solar reduction, the different intensity, and the obtained yield, considering different types of species. And the best results were observed, you can see here also with the reduction, of the solar radiation, that berries like, we can consider raspberry, cranberry, strawberry, all species that may need a lower solar radiation and could allow a good production, and also some, fruit species. Whereas you can see here grain, cereals, forages, or other vegetable crops, there is a more significant reduction of the yield compared, to relative solar radiation. Going back to our experiments, I am now showing you results conducted in Veneto. This is in the Valpolicella area with a pergola training system, and results of 3 years of observation. And in this case, after 3 years of experiments, we noticed important results. First of all, the reduction of the maximum average temperature. So during the growing season in summer in the vineyard, we noticed that the highest temperatures were recorded, of course, outside in full sun, whereas below the panels we noticed 1, 2, sometimes even more Celsius degree below the highest values recorded outside. We can see here also, in these graphs, the different temperatures of the two plots, below the solar panels and in full sun. Also, the solar temperature, the soil temperatures was different, with higher temperatures recorded outside in full sun, whereas the shade of the panels reduced the temperatures also 1, 3 Celsius degrees. But what was very important and was a noteworthy value was the higher soil metric potential recorded, outside below the panels. So there was more water available for the roots of the vines below the panels. So the vines, faced no stress condition, or anyway, a stress condition of lower intensity when compared to the vines grown outside in full sun. And this was true particularly during the hottest days of summer, July, August. And we have also to consider that Veneto is not a very hot region with respect to southern regions in Italy. Here also we can see with a thermal camera the difference, in the temperature between the temperature outside in full sun of the canopy and the canopy below the panels, and the reduction was even of 2-3 Celsius degree below the panels. Here I show you some phenological, some physiological data, such as the transpiration, or the photosynthesis, or the leaf water potential. And you can see that the data were recorded at morning and at midday. And there were differences during the 3 seasons in both plots, with values that were generally, for example, photosynthesis lower in the morning, so better values outside, of course, when temperatures were rising outside in full sun and was not very hot. But from 11, 12, 1 p.m., you can also observe as the photosynthesis was, or even the transpiration was higher outside, inside the agrivoltaic plot. And also with regards of the stem water potential, you can always see that the values were always better below the panels with respect of the outside. So vines were in less stressful conditions below the panels, with positive effects on also on the production. So differences were significant in transpiration, photosynthesis, and leaf water potential. In these pictures, you cannot see in these graphs the difference from morning and midday for transpiration. You can see as in agrivoltaics, transpiration was lower in the morning, but during the day, during the midday, values were much better, in the agrivoltaic systems. With regards of the leaf stem potential, values were always better in the agrivoltaics plots with respect, and this is very important in many Mediterranean countries that in the later years are facing problems of very high temperatures during spring and summer, low water availability, reduction of precipitations, and so the panels can be support to face this, this changing climatic condition. With regards of the yield, we can say that we observed some differences for the two plots. In general, the yield was higher in, although not so significant, was higher in full sun with respect of the vines covered by the panels. But we also observed a general higher content of soluble solids outside, of course, because of the higher radiation, with respect of the shaded condition. But below the panels, we observed a higher filterable acidity, a lower pH, and this is particularly important for fruits that are appreciated for a better balance between sugars and acids, or even for wine varieties for producing, white wines or sparkling wines. And you can see also in details the difference in the content of the malic and tartaric acids. And of course, we observed a reduction in the polyphenols in the berries shaded by the panels, and also the total anthocyanins. So the colors of the color of the berries was generally lighter. Although you can see there is not such a big difference between the two different conditions. But anyway, it will always depend on the intensity of the shade, because higher intensity, will cause more negative effects on the accumulation of such pigments. Then from Veneto, we move down to Puglia, an important region for fruit production, for table grape production, for wine production. And we investigated several physiological, morphological, and yield components with different devices. The experiment is currently carried out in the Svolta farm, that is in the Gioia La Terza countryside. You can see here an image, a picture from a drone of all the covered vineyard. Anyway, we are also setting up this. We started last year also, apart from grapes, trials on other different fruit crops. And we measured, different parameters. So in particular, the different, radiation. So in particular, the photosynthetic photon flux density, the PAR, also the PSS. And we also at the end, at harvest, we carried out microvinification in order also to taste the different wines obtained below the panels. We can see in these pictures that we consider two sides, two parts of the vine below the panels, because there is, a side that was more shaded, with respect to the other side that received was less shaded, So during the day, because this fixed panel facing south, there is a difference, on the irradiance, the radiation getting on the leaves of the vines. It changed during the day, and of course during the season, from June to July to August, even to September. But anyway, we observed, a general then balance of the yield, because the photosynthetase moved from the leaves of the different parts. And this is also a kind of drawing that we obtained from our data. So you can see the vines outside in the open field with an higher red-far-red ratio, a higher evapotranspiration, a lower vigor of the vines, a significant lower amount, because in Puglia, the climatic conditions are very different from Veneto. In summertime, there are very high temperatures, and sometimes it doesn't rain for weeks or months. And we observed below the panels, we can see different condition of shade on the shoots, with more shaded shoots and clusters, less shaded shoots and clusters. And we observed a significant reduction of their temperature, an increase of the moisture in the air below the panels, a significant reduction of the temperature in the soil, and a significant increase of the humidity of the soil, of the water availability in the soil, because we monitored with soil sensors the matrix soil potential, either in the soil covered by the panel and also in the soil in the open field. Here you can see some results about, you know, the light, about the radiation outside in the open field in full sun, and below the panels with the side which received more light and the more shaded portion of the vine. You can see there is a significant difference, you know, from the or even on the vine, the two different. So you can imagine the trunk and the two cordons. So there is a difference of lights on the left cordons with respect to the right cordon, and you can see also difference in the different radiation, blue, green, right, and so on. Here you can see the leaf water potential that we measured with devices during the day in June, July, and August. You can see how outside the potential was much lower. You can see, so the vines were facing, you know, a kind of stressful condition, in particular in June and July, whereas below the panels, the condition was much better. So the leaves were in better condition, and the vines faced we can say a very low mild stress with respect to the outside. We also measured, you know, the stomatal conductance, and you can see the difference also between the significant difference between the vines below the panels and the vines outside the panels, and also between the two portions of the vines. And in this, we summarize these results about the conductance, the stomatal conductance, which is directly connected with photosynthesis, with transpiration, you know, with the millimoles of water that are transpired. And you can see the higher values of the partial shaded vines, even in the morning and even in the afternoon. There was also, you know, photosynthetic activity. With respect to the control outside, where we detect significant lower values. So the partial shade had positive effects on the stomatal conductance. Here also you can see some other values like the SPAD values and the fluorescence, and always the values outside are worse with respect to the shaded vines. With regards of some morphological parameters, we can see also the positive effects of the shade in both conditions with respect to the outside on the total shoot leaf area. So we see that the vines below the panels had a higher leaf surface with respect to the outside. And this was related both to the main shoot and also to the lateral shoots, the secondary shoots. So both the primary and the secondary shoots noticed, you know, a greater surface area, and the total leaf area yield ratio was much better. We can say almost optimal below the panels with respect to the outside, so where we detected a very low yield. Also, a difference was noticed for the shoot number, but confirming the results about the transpiration, the conductance, the more water available in the soil. Also, the water content in the canes and in the leaf was higher below the panels with respect to the outside. So the vines were better hydrated in the panels. Also, some effects were also noticed on another parameter, that is the number, you know, of primordia of inflorescence in the buds. But anyway, this is another. With regards of the yield, you can see the difference that we noticed, but you can also see from the pictures below the difference that in 2022 was very, very clear between the panels and the full sun, because it was a very hot and dry season. So from this data is clear that the positive effects on the yield, the bunch weight, berry weight, and the yield was significant and will be always significant when we grow these species, fruit species, or even other horticultural species in semi-arid, arid, or in areas that are facing condition of high temperatures and the low availability of water, And the color was also affected. And of course, in general, the berry of the cluster below the panel presented, a lighter color. And this was reflected in the successive microvinification. So as in order to draw a line from this data in Puglia region, we observed positive responses of the vines below the panels. In particular, we have also data from 2023, and they confirmed the data of 2022, but the season was a little bit better from a climatic point of view. So the difference was a little bit less evident. But anyway, we noticed significant differences between the panels, the agrivoltaic plot, and the full sun plot, with positive responses for yield, positive responses for the vegetative activity of the vines, for the weight of water savings, for a better microclimatic condition for the vine. In this, now I just show you in a very fast way, because I think I'm very out of time, and I'm sorry for this. So I'm just showing you some pictures of the vines that were for the winemaking that was conducted in this year. So we obtained from Svolta in cooperation with CSFA wines that were less alcoholic, more acidic, and with a different red style. We can also see a lower intensity of the red color. So these are some of the wines that we tasted, that we produced, that were bottled by the Svolta farm, as you can say, agrivoltaic wines. We can say also good results. I can say maybe much better results with white varieties of wine grapes. And this is Falanghina. We can see the low pH that we obtained, also a good acidity, in particular for the malic acid, and a good alcohol. Primitivo di Gioia del Colle, and you can see also Antinello, Minuto Rosa, Antinello. So we had a different kind of wines, maybe a little bit less alcoholic with a different color, but maybe this is also an opportunity, a chance for the growers to diversify the production and go towards, also the attraction of lower alcoholic wines, or sparkling wines, or also wines with a different light color that ranges also from an orange, a light red, rosé wines. Anyway, we are also going on with our works, and we set up new experiments with other fruit crop species like pear, like pomegranate, like fig, like Japanese citrus, and also berry. And we hope to get also data from these species in the next years. But anyway, at least in Puglia, in the climatic pedological condition of southern Italy, results, practical results, so yield, vinification, of agrivoltaic vineyards were positive. Thank you so much. And if you need to contact me, this is my email, but anyway, you can find my contact on the site of the University of Bari. And maybe if you are in Bari, Gioia del Colle at the Farms Volta Wine, you will taste these agrivoltaic vines, maybe under the panels, maybe close to the vines. Thank you so much for your kind and patient attention. And sorry to be a little bit out of time for my presentation. Thank you so much.
Thank you, Giuseppe. And it's important that the research is still ongoing, work in progress, because we need to more.
We need data, Federica. We need data to explain the positive aspects and the drawbacks of the system, this system, where we can have agrivoltaic system, which are the better place, the better locations, which crops can be grown.
I stop you because
sometimes I talk too much, I know.
I will introduce Gabriele Canali, Professor Gabriele Canali, professor from University of Catholic, and is a professor of economics of the agri-food system. So welcome, professor, and would you share the presentation?
I think we don't hear the professor.
The presentation is okay?
Professor, the audio is not working. Try to select the microphone in the audio device, bottom left.
Can you hear me now?
Yes.
Yes, okay.
Please go ahead.
Yes, thank you. Good afternoon.
Okay. So good afternoon. Sorry for this delay. So I was introducing my presentation. The presentation is really the beginning of a work that we are doing with our spin-off, which is VSafe, which is a spin-off of the Catholic University. What we just started to do is to develop, we are developing a model to evaluate from an economic point of view, starting from technical information, let's say somehow the cost-benefit analysis of agrivoltaic systems, so the sustainability, considering overall all external costs generated by different sources of energy, different technologies, and this one, and of course, ecosystem services provided by different approaches, different energetic systems. So the focus is the challenge. Of course, this is a big challenge. And what I will share with you is just an introduction to explain what the goal of this work. The work is at the beginning. We have, and we are eager to look to get in touch with colleagues and other researchers, and this is an opportunity. So, for example, I will get in touch for sure with Giuseppe Ferrara after this meeting, because we need technical information in order to develop and to finalize our model. So, what is the idea? The idea is to we start from basic information. Of course, these are piece of information that you all know, but it is just a way to summarize and to explain the rationale of our model. So soil, of course, is a resource. We know soil is producing many ecosystem services, and again, this is something that everybody knows. So provisioning services, and we are focused quite a lot on these services because we are talking about food, of course, wine, also food and beverages, biomass, raw materials, energy, of course, but also other services, cultural services and regulation services, very important, because we know that talking about agricultural area, agricultural land, carbon storage could be very important in one way or the other, erosion and nutrient control, protection and mitigation of extreme hydrological events. And so many other aspects are regulated by the soil. And of course, also support services. Soil is providing many services in terms of decomposition and mineralization of organic matter, habitats, biodiversity, conservation, etc. So this, of course, is a starting point, but we know that this resource is, this soil is a resource, but it is a very scarce one. So we are losing soil. And this is a very critical tool, a critical issue, especially in Italy, not only in Italy, but for sure in Italy. You know, we are many, the population in Italy is very, is high, the population density is high, and our land, our environment is very difficult. So we have many areas with many mountains, hills. So population is very much concentrated in the more fertile land. So we have consumption of soil, which is most of the time agricultural soil, due to request, demand of soil for other reasons. And what we are losing is agricultural land, and which is already a very scarce resource for Italy in particular. And we have, moreover, hazard contamination by chemical products, which is another way to lose, of course, soil as an agricultural soil, a soil that we can cultivate. And of course, we have another very critical issue, which is the risk of desertification. We have many areas where, because of the decrease in the percentage of organic matters in the soil, we are at risk of desertification. So we have many areas. So we are losing soil. We have the risk of desertification. We have contamination. Of course, this is putting a high level, a high value on the agricultural land. Of course, I don't need to explain how the agrivoltaic could help to make a better, a more efficient use of this scarce resource. Of course, if we can combine in an efficient and effective way the two activities, the possibility to get electricity, produce electricity from voltaic panels, and keeping together at the same time a good level of production, a good level of agricultural production, and production not just of agricultural products, but also of those ecosystem services that we just mentioned before. So we must remember that the agricultural sector, agricultural land, is not providing only food, feed, fibers, but also many ecosystem services. Of course, the ecosystem services are not valued by the market. This is the main problem. These services are not valued. They do not have a monetary value. And this is part of the problem. We don't know exactly how much ecosystem services we are producing or not producing. And of course, we know even less about the value of these ecosystem services. This is why it's very important, let's say, first of all, to gather information, to evaluate properly the best balance about biomass production, the agricultural production, and the energy production. So talking about agrivoltaic, we need to find the appropriate, the effective and efficient balance between agri and voltaic. We see it is very easy, clear, but in practice, this is very difficult because we need to focus with specific areas. So Puglia is different from Veneto, like mentioned in the previous presentation, and water availability is different. So the equilibrium could be different. And so we need to evaluate properly to get a tool so that we can evaluate how this balance could be appropriate and, let's say, more sustainable in one specific area and in another different specific area with reference to different production, different agricultural use of the land below the voltaic panels. Of course, there are many aspects that we need to evaluate in order to make this evaluation: soil and climate characteristic of the area, the economic, let's say, vocation of the area, incentives and costs in the local market. You may have specific products with a high value or products that are able to feed, let's say, an agri-food chain with a strong economic impact, economic and social impact on a specific area. Just to mention as an example, the Primitivo in Puglia has been able to revitalize a very important part of the viticulture activity in Puglia. You know, up to 15 years ago, they were simply, in many areas, they were producing wine, but just to produce alcohol, because the common agricultural policy was pushing in that direction, and it was a way to support another kind of viticulture. So the risk of, grabbing out the vineyards was very high, but then the ability to discover the good opportunities that were provided by the market, so created an economic area, and so incentives in the local and also in the international markets. Social networks of the area. Again, social networks are important because they may influence the value and the benefits or the cost generated by agrivoltaic in the area. And access to training and research, of course, and the legislation and guidelines for agrivoltaic are, again, very, very important. So many issues can be, the relationship could be very different in different conditions. I don't want to stress too much this point, but of course, we may have positive effects by agrivoltaic production. So we may improve cultivation in dry and arid areas. And the last example of Puglia in the last couple of years, 2022, 2023, the case that was mentioned was 22, I guess. So a very hot and dry year. The benefits have been very clear in the previous presentation. So you can improve the resilience of an area to climate change. This is very important, for example, for many parts of southern Italy that are below, they are very under stress from this climate change, in particular in the last year. You know that it is not raining in Sicily since many, many months. So making agriculture economically more sustainable, well, now perhaps it is not really sustainable or could be out of the market. And of course, you may have support generate positive effects also in terms of making small rural community energy self-sufficient from the point of view of the energy production. Of course, we may have conflicts, or we may have between agrivoltaic and voltaic and agri. So you may have the negative effect to decrease the food self-sufficiency, because you may prefer to produce electricity, and at the end, the agricultural activity that you say you are doing below the panels is not really a big deal, a big activity, or it's just something residual. So with a real loss of production and productivity. And perhaps it could be also that there is not much of an interest in producing under specific panels, for example, according to the technology applied, but also in special conditions. So in that case, of course, the conflicts could be very important. And of course, we may have also other conflicts, like it depends on how the market of energy is moving, and so you may increase the community self-sufficiency of the communities, or you may again, produce electricity and to benefit landowners on one side and energy producer and traders on the other. So the overall effects on the economy and the local economy could be, mixed and perhaps also negative to some extent. And we may have also loss of landscape and natural areas as a result of a badly defined and negative projects of, let's say, agrivoltaic. In other cases, we may have a situation where the benefits could be irrelevant, and so at the end it is more irrelevant. Now the question is, what does it mean to ask ourselves if the agrivoltaic is sustainable? We need, of course, to provide an answer, possibly a good answer, a comprehensive, holistic answer. We need to expand our view from individual perspectives. So from the perspective of companies, individual companies or individual farmers, to a more local community perspective. And we need to open our mind and open the evaluation to consider the total economic value approach. So to consider all the benefits for individuals, communities, and the overall, population of the, let's say, in the global, from the global point of view. We can answer, the answer could be, of course, potentially agrivoltaic, we expect, and we would say, yes, of course it is sustainable, because we are making a best use of a scarce resource. We produce both electricity in a sustainable way, because we are producing, getting electricity from the sun. So we are not using, we reduce CO2 emission. But we need to evaluate clearly all the aspects, and in particular, of course, we need to evaluate the effects on the local economy, so all the economy, so and consider, for example, the starting point of my presentation. So the fact that we could simply lose agricultural land without losing many benefits and many, or at least few benefits, few services that the agricultural land could produce, could develop. So we need to be focused. The question is, we need to evaluate place by place, a specific situation, and the model must be able to consider the specific situation. In order to evaluate, to develop this model, social cost-benefit analysis, we need to consider both aspects. On one side, the cropping system, on the other side, the energy system. And we need to consider production cost, revenues in both cases, tools, intervention, public intervention, support, but especially environmental costs and environmental benefits. These are the key points that we need to consider for both the activities. This is really the key issue. At the end, the model, if we are able to evaluate from a technical point of view first, all the positive and negative aspects, costs and benefits for individuals, for local community, and for, let's say, the population in general, the society in general, of the two activities, we can provide at the end an evaluation that could be expressed in terms of euros, so in monetary value. This is the challenge that we are facing. I must say that we have developed already a model like this. to evaluate in a different case, but you may understand that there are very strong connections, to evaluate the final cost-benefit analysis from a social point of view for the realization of investments in green the cities, in public parks. So we have been able to evaluate from a technical point of view the role of these public parks in the cities, public and private potentially, but in our case we developed a model for public parks in the cities, green areas. So we have been able to evaluate the from a technical point of view, the CO2 that is, stocked into these parks, into the trees and so on, the reduction of the emission of pollutants, the role of reducing water runoff, capturing water, and creating water sinks in the soil, biodiversity preservation, positive effects in terms of increased values of houses in the area around of the parks, and other positive effects in terms of reduction of, for example, of the negative effects of loud sounds, or if you have a train, if you have a railway, if you have a high-speed road, so you may have a huge problem of pollution, and so in that case the parks can provide huge benefits that we have been able to quantify and to translate into value. And with that evaluation, at the end you can say, yes, this investment is generating, it has this cost, but is generating these benefits that are over time equal to 1, 20, 30 times the value that has been invested. So the challenge here is to do something similar with agrivoltaic system. We have been, now I've been very broad in my presentation, but the goal is to apply this model to specific cases in order to focus on a specific analysis. And this is what we are starting to do in a couple of cases, and we would like to increase also the case that we are that we can deal with this model in order to finalize the definition of the model. And so this is for us also an opportunity to possibly to get in touch with researchers and to gather information and to create collaboration. Thanks for your attention.
Thank you, Professor Canali, and we have some minutes for to answer to the question. So, Paolo.
Yes, thank you, Federica. We got some questions, so we still have some minutes. And I saw some was already replied, but we have some more general questions. So the first one is for Professor Marinello. Assuming that we want to compare an electrical tractor with a normal one of the same size of power, what would be the difference in the weight of these two models? Eventually, does the higher weight of electrical tractors from the batteries impact the compaction and consequently the fertility of the soil? Thank you.
Yeah, I already tried to mention about this in the presentation, and if we compare the same power and the same autonomy for big tractors, the electrical one supplied by batteries wouldn't be enough how to say, would be too much heavy, and the impact on soil would be very high. But if we are looking at small tractors, let's say with power lower than 80-90 HP, it is true that the batteries are quite heavy, but we have to consider that we are saving the weight for the gears, for the transmission. So eventually, in the case of small tractors, it is true that the batteries are not reaching the autonomy of a fuel engine, but I would say that they are quite comparable in terms of power and performances. What they are still not comparable is the price, and still electric tractors have a cost that is difficultly returned unless they are used for many hours per year. And this is probably also an answer to the second question I can see, that is if electrification and conservation and robotics offer an actual opportunity for modern agriculture. And answering to Maurizio, yes, they are an opportunity, but still there is this kind of issue that is related to the price. And secondly, we shouldn't forget about the maintenance. For normal tractors, we have a network of shop floor that can provide assistance for any kind of problem tractors or other machine might have. For electrical vehicles, still we are not ready, and this is true probably also for cars. Still we are not ready to have a sufficient network of providing assistance. So the two main problems at the moment are assistance and cost. And for robotics in particular, also the official regulation that do not allow to leave heavy unmanned vehicles working without control in the field. So there is still some legal and economical issue, but in my perception, this is somehow the trend that is well tracked for the future.
Thank you so much. So we have other two questions. Those are for Professor Ferrara. It's related to the older wines. Thank you for this presentation. Congratulations for this work. Can the results be different when we deal with the older wines? I mean, not so. I imagine in my interpretation is they mean not for newly planted vines, but for vines already existing there.
Yeah, I think the question is related to vines 50, 60, 80 years old that we have in different Mediterranean areas. Of course, some differences can arise because we have seen differences from one season to another, from one location, Veneto, to the other location, Puglia. But anyway, we will see for sure some positive effects, such as on the more water availability for even for the older vines, maybe a little better vigor, although the older vines generally present a lower vigor, and of course also the color will be influenced by the panels, but also for these older wines, I think the possibility to have these panels, at least I can imagine about this for very marginal areas, for very difficult areas. I'm thinking about some location even in Puglia, in Sicily, or Spain, in Greece. We can also a little bit protect the vines from the damages from the high solar radiation. So from problems like sunburn on the berries, which negatively affects the quality of the vines, the quality of the grapes. And maybe we can also get very good products from wines obtained from these older wines. But for sure, there will be some differences. But these differences, I think, if we look at the balance, will go towards positive effects more than negative effects.
Thank you for this answer. Are there any other question? Because we could
There was, Paolo, another
webinar.
question.
Yes.
There was another question. One is saying, is there someone working on cable feed tractor for agrivoltaics fields? So just to answer,
Yeah, sure.
yeah, there are people working on cable feed tractors. There was one introduced by John Deere, a new one produced in Italy that is called OXE, and that is from company in the north of Italy, but they were for cable feed tractor, but I'm not sure they were for agrivoltaic, or they can fit agrivoltaic. And there was also another question about a small farm. So it is easy to implement large, big technologies and new technologies and everything in large farms. What about small farms? Yeah, that's quite a challenge. Let's say that, of course, it depends on the specific crops. In the previous presentation, we were hearing about vineyards. So, of course, it depends on the value of the crop. I would say that at present, the implementation of robots and the electrical device are often used by farmers, not just as an agricultural tool, but also for their marketing purpose, because being electrical, of course, has also an appeal on production and might also reduce the carbon footprint. So what I would say that is that the appeal in the future will disappear once this vehicle will become common. But keep in mind that on carbon footprint or carbon credits, there will still probably a lot of interest, probably even small farmers might increase their carbon credits using electrical vehicles. And of course, again, we are speaking about small vehicles that are more affordable for small farmers.
Thank you. I think we exhausted all questions. Yeah. Thank you so much. Before we close this seminar, I just wanted to say thank you for the participation, and this from all the partners in the Symbiosyst project. So I will just share with you, because there was a technical problem with you. So this is Symbiosyst, all partners. I hope you can see them. So thank you to everybody for the participation. We will come up with a further training webinar on the most hot topics related to agrivoltaics research and development. Next appointment will be for October, so we will get very soon new news about the incoming topic and the date. I really want to thank you from all the partners of Symbiosyst project, all the contribution today, and for the effort. We know it's always borderline and really new topics. So, and we must all make an effort to understand how to relate the knowledge you already have to such new challenges, and this is really valuable. So thank you so much to Professor Canali, Marinello, and
Thanks
Ferrari.
a lot for their contribution, yes, and the time. Okay.
Thank you, everybody.
You're welcome.
Good
Thank you.
Thank you.
Bye-bye.
Bye.
Bye.
Thank you.
Thank you very much.
Thank you, everybody.
Bye.
Bye.
Bye-bye.
Bye.
Thank you.